Okay, section 1.6, solving systems of equations, part 2. We talked about the graphing method in the last video. We're going to get right into the other methods. There's 3 methods in total: graphing, substitution, and elimination. And later on in your mathematical life or career, you might learn about solving by matrices, but we aren't going to talk about that right now. So, substitution method, let's talk about that first. This method relies heavily on the notion of equality. So if I say that x and y are related to 1 in this way, so I set up an equation, right? I set up an equation in this way. If I solve for one variable, then I can take what that variable is equal to and put it into the other equation. So let me show you how to do that. This one, it doesn't matter if I start with x or y. Okay, so for this one, I'm just going to add y to the other side and solve for x. So I get this: x equals 1 plus y. Okay, so now I can take that 1 plus y, which is what x is equal to, and I can move it and put it in for x over here, right there. Okay, that was bad. Try again. Cresswell, come on. I can take this and put it in for x right here. Okay, so I'm going to do that, and here's what it will look like. All right, so it would be 2 times, and I'm plugging in 1 plus y. So 1 plus y, plugging that in. And remember, I'm plugging that in so that I can get a one variable equation here. So before we talked about graphing, we graphed both sides, but I don't want to do that now. I want to try and solve this algebraically, and each one of these equations here and here has 2 variables in it. I can't just solve for x or solve for y and get the answer. So I'll distribute the 2. I get 2 plus 2y plus y is equal to negative 4. 2y and y is 3y, so I get 2 plus 3y equals negative 4. I'm going to subtract 2 to both sides, so I get 3y equals negative 6. And then I get, when I divide by 3, I get y is equal to negative 2. Okay, so that's part of my answer. Remember, the solution to these has to be an x and a y coordinate. Think about the intersection of 2 lines. It's got to be x and a y where they cross. So to get the x, then, I'm going to take and just plug negative 2 in right here. Okay, so I get x is equal to 1 plus negative 2. 1 plus negative 2 is negative 1. Okay, so my solution then is this coordinate, or this x and y, negative 1, negative 2, right here. Okay, so that's how you use the substitution method. You solve for either x or y, and you substitute in to the other equation. Okay, so let's go ahead and go to the other method here, the elimination method. All right, so the elimination method relies on this idea that we can add equations together, okay? And if you want to know more about why this works, it's not obvious or intuitive why it might work. I can certainly explain it more in class or maybe in another video. But right now I just want to tell you that you can add or subtract equations, and that can turn out to be really useful. So what I'm going to do here is I'm going to add these 2 equations together, and we'll see what happens. The idea is to eliminate one of the variables so that I can solve an equation that just has one variable in it. Okay, so when I add these 2 equations together, 2x plus x gives me 3x. Y plus negative y, that's 0. And then I get negative 4 plus 1 is negative 3. So I get this: 3x is equal to negative 3. If I divide both sides by 3 now, I get x is equal to negative 1. Okay, so that's half my answer. Remember that the solutions to these are are a point, x and y. So I'm going to get the other variable, y, I'm going to plug in negative 1. I can plug in negative 1 to either equation. Okay, this one right here is simpler, so I'm just going to use that one. So I'll go negative 1 minus y is equal to 1. I'll add 1 to both sides. I get negative y is equal to 2. Times both sides by negative 1, and I get y is negative 2. So I get this for my solution: negative 1, negative 2, which is what we should expect, because you might notice these problems are the same, one on the left and on the right. So we would expect that we would get the same solution. Okay, so two different methods to do those. Whenever I use the elimination method, by the way, I always, when I use the substitution method, you should separate the equations kind of like it is here. It's much easier to do if they're not stacked on top of each other. Okay, so now we know three methods: substitution, elimination, and graphing. Let's see if we can look at these problems and figure out what's the best method to use. Okay, well, that was interesting. All right, so here, in this first one, I look at this and I see that one, it's not in slope-intercept form. Neither equation is in slope-intercept form, so graphing is probably not the easiest way. Substitution doesn't look like it's that easy because I've got coefficients that are other than 1 in front of all the variables, okay? So I'm going to hope that elimination is the best method. In this case, it is. Now, if I just add these equations, nothing will get eliminated like the previous one. So I need to multiply one or both of these equations by something so that when I add them, something actually gets eliminated. So what I notice is that this is a positive 3 and this is a positive 3. If I add them now, I'll get 6. But if I times this top equation by -1, then I'll get a -3 there, and when I add them, the y's will actually get eliminated. Okay, so I'm going to times everything in that equation by -1. This, this, and this. Okay, so I'll end up with -5x minus 3y plus 19 is equal to positive 19. I'm going to leave the bottom equation alone. So the bottom equation, I have 8x plus 3y is equal to -25. Now, I'm going to add the equations together. And so -5 plus 8, I get 3x. -3 plus 3 is 0. Here I get -6. And then when I divide by 3, I get x equals -2. Now, I'm not done yet. I have to go figure out what y is. But that's okay, because once I have one variable, I can pick either equation over here on the left, and I can just plug the number in. So if I plug in -2 for 8, this is what I get. So let's draw a line here. So I get 8 times -2 plus 3y is equal to -25. And I'm going to spare you the time here. You do some algebra. You might want to do it and then check and see what you get, but I'm going to get y equals -3. And so my solution is -2 comma -3. That's my answer. Okay. All right, on the next one. You should give the next one a try for yourself. You're going to probably use elimination method. That's probably going to be the best method because y or x is not by itself. It's not in slope-intercept form. Neither one of them is in slope-intercept form. Okay, so go ahead and give that one a try and see what you get. And I am going to solve it. Okay, so this one, I noticed that I have, I've got a 9 and a 15 down here, and a 5 and a 3 right here. So what I think is, if I multiply this top equation right here by 3, it would give me 9, which would be good because there's a 9 right here at the bottom on the second equation. But if I times it by a -3, that's even better because it'll give me a -9, which will eliminate the y's. And I should say too, it doesn't matter whether you eliminate the y's or the x's first. It's just whatever is easiest, whatever matches with the equations that you have. So I'll times this by -3. I'm going to leave the bottom equation alone. So, but -3 times all of this will give me, let's see, -15 minus 9y, 15x minus 9y, minus 1 equals -156. I'll leave the bottom equation alone. That would be 15x plus 9y is equal to 54. I'm going to now add these equations together, and look what's going to happen. I'm going to get 0 for the x's too. So I'll get 0 plus 0 is equal to, this turns out to be -102. So I get 0 equals -102. That is not a true statement, right? 0 is not equal to -102. All the variables went away. That means that there's no solution, okay? This statement is not true. That implies no solution. All right? This system then, we would classify as inconsistent. We learned that term in the other video. Okay, it's an inconsistent solution. The last thing that I would say about this is it's possible for this to happen and for this statement that you get to actually be a true statement. Okay, so if you got down to something like 0 equals 0, then we would say that that has a solution of all real numbers, or all reals, and that solution is classified as consistent and dependent. We learned that was the one where the lines, if you were graphing them, would be on top of each other. Okay, so that's the other two methods. A lot of practice with these is really going to help, so make sure that you're practicing, checking your answers, checking your work, and getting help from me if you need it.